Right now, at this very moment, two cities sitting in the same country, under the same flag, separated by roughly 400 miles of land, experiencing what can only be described as completely different seasons. In London, temperatures are climbing toward 20 degrees Celsius. People are sitting in parks in t-shirts. Cafe terraces are full. The sky is bright, and the air is warm enough to make you genuinely believe summer has arrived. Meanwhile, 400 miles to the north, Edinburgh is sitting under a cold northerly wind that is dragging temperatures down to 9 degrees Celsius, with a wind chill that makes it feel even colder. There are wintry showers falling over the highest Scottish ground. The exposed coasts are bitterly cold, and the people who live there are not talking about summer. They are wondering if winter has returned. Same island, same day, same country, 20-degree temperature difference. If you have ever looked at a UK weather map and wondered how that is physically possible, this video is going to explain everything. From the real-time atmospheric mechanics, driving this specific split right now in May 2026, all the way back to the fundamental geography and climate physics that make Britain one of the most weather-complicated small patches of land on the surface of the Earth. Let us start with what is actually happening in the atmosphere right now, because the current situation is a textbook example of one of the most fascinating and frequently misunderstood features of British weather. As of this weekend, May 8th and 9, 2026, a cold front is draped across the United Kingdom, running roughly from southern Scotland through northern England. A cold front is a boundary in the atmosphere where cold air is actively advancing and pushing underneath warmer air. To the north of that frontal boundary, cold northerly air that has been pulled down from higher Arctic latitudes is in full control. Edinburgh and much of Scotland are sitting firmly behind this cold air mass. The northerly wind is not just cold in the temperature sense. It has come directly from polar regions, and it is carrying the thermal signature of those latitudes into a country that, in early May, was already flirting with warmth. Bradford, Sunderland, Newcastle, and Edinburgh are all experiencing outbreaks of rain, brisk northerly winds, and the kind of cold that is genuinely unseasonable for the time of year. Forecasters have specifically flagged that some of the heavier showers over the highest Scottish ground could briefly turn wintry, sleet or snow falling in May in a country where most people outside Scotland have long since stopped thinking about winter clothing. To the south of that same frontal boundary, the situation is completely reversed. Much of central and southern England, along with parts of Wales, is sitting in a pocket of milder, significantly warmer air that has not yet been swept away by the advancing cold front. London, Worcester, Bournemouth, and other southern areas are reaching 18 to 20 degrees Celsius. In sheltered spots where the sun breaks through the cloud cover, it feels genuinely warm, the kind of warmth that justifies sitting outside. The air mass over southern England right now has a completely different origin story to the air sitting over Scotland. It has traveled from the south, carrying warmth from continental Europe, or from the relatively warm waters of the Atlantic subtropical regions. Two air masses, two completely different origins, two completely different temperature profiles, and a front sitting between them like an invisible wall that divides the country into two entirely different weather experiences. The mechanism that determines where that front sits, how long it stays in place, and which direction it moves, is something that affects British weather more than almost any other single atmospheric feature on the planet. It is the jet stream, and understanding what it does and why it does it is the key to understanding why the north-south weather split is not just a bizarre coincidence of one particular weekend, but a recurring, deeply rooted feature of how the UK's climate works. The jet stream is a narrow, fast-moving ribbon of air that flows from west to east at roughly 35,000 feet above the Earth's surface. Far above the weather we experience at the ground, but profoundly influential over it. It forms at the boundary between cold polar air to the north and warmer subtropical air to the south. The sharp temperature contrast between those two air masses creates a pressure gradient that drives winds of extraordinary speed along this narrow band. In the strongest configurations, jet stream winds above the UK have been measured at over 400 miles per hour, faster than the cruising speed of a commercial aircraft. What the jet stream does to British weather depends almost entirely on where it is, positioned relative to the country and how it is shaped. When the jet stream runs in a relatively straight west to east line directly over or near the UK, it acts as a conveyor belt for Atlantic storm systems, funneling low-pressure weather systems one after another across the country and delivering the classic British combination of unsettled skies, wind, and rain that the rest of the world associates with Britain. When the jet stream bends northward, what meteorologists call a ridge, it pushes the cold polar air back and allows warmer air from southern latitudes to flood northward into the UK, producing the sunny, warm spells that feel like genuine summer. And when the jet stream bends southward, what meteorologists call a trough, it opens a direct pipeline for cold Arctic or polar air to push southward into the country. bringing the kind of bitterly cold, sometimes snowy conditions that Britons tend to describe as unseasonable, regardless of when they arrive. The situation in early May 2026 involves a fragmented and relatively weak jet stream that is not driving a clean, unified weather pattern across the whole country. Instead, with a cold front draped across the middle of the UK, the jet stream is essentially letting two competing air masses sit side by side. The cold polar air that has already pushed into Scotland and northern England, and the milder air that is still holding its ground across the south. The Met Office's 10-day trend analysis published this week described the jet stream as fragmented and weak, with little to drive any prolonged settled or unsettled conditions. A weather front, they noted, is acting as a dividing line between cooler air to the north and milder air pushing up from the south. That dividing line is what you see on the temperature map when Edinburgh reads 9 degrees and London reads 20 degrees on the same day in May. But to understand why the UK is so particularly vulnerable to this kind of dramatic north-south split, in a way that most comparable European countries are not, you have to understand something about its geography that is easy to overlook when you are just looking at a map. The United Kingdom straddles the higher mid-latitudes, sitting between 49 and 61 degrees north latitude on the western edge of the European continent. That positioning places it almost permanently within or very close to the path of the polar front jet stream. The country is not large enough to experience the kind of continental climate that dominates much of Europe's interior, where distance from the ocean moderates the extremes and creates more predictable seasonal patterns. Instead, the UK sits right at the intersection between cold polar air from the Arctic and warmer maritime air from the Atlantic, with the jet stream passing almost directly overhead as its natural position for a significant portion of the year. Small shifts in that jet stream, a few hundred miles north or south, translate into dramatically different weather outcomes for a country that is only about 600 miles long from its northernmost point to its southernmost tip. Scotland sits at roughly the same latitude as Moscow and parts of southern Canada. Edinburgh's latitude of 55.9 degrees north places it considerably further north than most. People realize, further north than Copenhagen, further north than Amsterdam, further north than the southern tip of Greenland. The reason Edinburgh's climate is not as brutal as those latitudes might suggest is the moderating influence of the North Atlantic Current, the continuation of the Gulf Stream, which keeps the waters surrounding the British Isles significantly warmer than they would otherwise be at those latitudes and prevents the kind of deeply cold winters that comparable continental latitudes experience. But that oceanic moderating influence does not mean Scotland is immune to cold air intrusions when the atmospheric circulation delivers polar air directly southward. When a northerly airflow establishes itself, as it has this weekend, Scotland's high latitude means it gets the coldest, most Arctic-influenced air first and feels it most severely. London's latitude of 51.5 degrees north places it on a par with the northern German coast, with Brussels, with parts of southern Poland. In European terms, London is not a particularly southerly city, but in the context of the UK's north-south temperature split, London's position in the far south of England means it benefits from two compounding advantages when a cold front is positioned across the middle of the country. First, the warmer maritime or continental air that resists the cold front pushes up from the south and southwest, and London is the first major population centre to receive its full benefit. Second, London sits at the heart of one of the most significant urban heat island effects in Europe. The city's dense concentration of buildings, roads, vehicles, and human activity generates enormous quantities of waste heat that raises urban temperatures by as much as 2 to 5 degrees Celsius compared to the surrounding rural countryside. When a UK weather map shows London touching at 20 degrees while Edinburgh sits at 9, part of that gap is genuine large-scale atmospheric difference between two air masses, and part of it is the concrete and tarmac of one of Europe's largest cities radiating stored heat back into the air above it. The north-south weather split that is playing out so dramatically this May weekend is not an unusual event. It is actually a recurring and deeply characteristic feature of the British climate that the Met Office and other meteorological services document repeatedly throughout the year. In autumn 2025, the Met Office's year in review noted that England saw a clear north-south divide in rainfall, with northern England recording levels that were 45% above average, its fifth wettest autumn since 1836, while southern England was only 17% above average. In the spring of 2025, Wales recorded its fourth driest March since 1836, while northern regions saw significantly more rainfall. In March 2025, the north-south divide in dryness was stark, with the south recording 16% below average rainfall and the north running 38% below, yet with opposite extremes at other times of the year. This back and forth is not random. It is the direct expression of a climate system in which the jet stream's position relative to a geographically elongated island constantly reshuffles which part of the country sits in the cold, polar air mass, and which part sits in the warmer, southern or oceanic air mass. The climate history of Britain is full of extreme examples of exactly this dynamic. In the Great Freeze of 1963, one of the coldest winters in recorded British history, the jet stream locked into a pattern that delivered persistent easterly and northerly winds across the entire country for weeks at a time. Rivers froze. The sea froze in places around the coast. Milk bottles froze on doorsteps. That event was the result of a sustained, deep displacement of the jet stream far to the south, allowing Arctic air to dominate the entire island without the Atlantic's moderating influence being able to push back. By contrast, during the heat wave of 2022, when temperatures in England briefly exceeded 40 degrees Celsius for the first time in recorded history, the jet stream had displaced far to the north, allowing an almost unobstructed flow of superheated air from North Africa and Iberia to surge northward across the Channel and into southern England. Scotland, true to form even in that event, remained significantly cooler than the south, with temperatures peaking well below the records set across England. The north-south split operated even inside an extreme national heat wave. The question that people increasingly ask when they see a weather map showing Edinburgh at 9 degrees and London at 20 in the same week is whether climate change is making these splits more extreme or more frequent. The answer that climate scientists give is nuanced but important. The background warming of the climate is increasing average temperatures across the entire UK, which means both Edinburgh's cold days and London's warm days are starting from a higher baseline than they would have 50 years ago. A day that reads 20 degrees in London in May 2026 would have been remarkable in the historical climate record. Now it is within the range of normal. A day that drops to 9 degrees in Edinburgh in May is still cold, but its frequency may be changing as the overall warming trend shifts the distribution of temperatures upward across all seasons. There is also a more complex and scientifically active debate about whether climate change is influencing the behavior of the jet stream itself in ways that could affect the frequency and persistence of exactly these north-south split patterns. Some research suggests that the rapid warming of the Arctic, which is warming at roughly 4 times the rate of the global average, is reducing the temperature contrast between polar and subtropical air masses that drives the jet stream's strength and directionality. A weaker, more meandering jet stream would theoretically produce more persistent blocking patterns, situations where weather systems stall in, place for days or weeks rather than moving through quickly. That persistence is what turns a temporary cold spell in Scotland into a prolonged freeze, or a warm spell in London into a genuine heat wave, rather than a few pleasant days. The scientific debate about exactly how much the jet stream is changing and what that means for UK weather extremes is not yet settled, but it is one of the most active areas of climate research in the atmospheric science community, and the implications for UK weather patterns over the coming decades are significant. What the Net Weather long-range spring forecast for 2026 described as a mixed picture with a flow often from the north or northwest, and a frontal boundary dividing the country is, in meteorological terms, almost a definition of a classic British spring. The transitional seasons, spring and autumn, are precisely when the jet stream is most variable in its position. Shifting northward and southward with changes in the temperature contrasts between the warming land and the still cold ocean, or between the retreating Arctic air and the advancing subtropical warmth. Spring in the UK is not a smooth progression from cold to warm. It is a battle between competing air masses, with the front lines of that battle running across the country in different positions from week to week, and sometimes from day to day. The result is the kind of weather that Britons have been complaining about and describing in obsessive detail for centuries: unpredictable, changeable, regional, and chronically resistant to any simple characterization. The north-south split that is making Edinburgh feel like November while London feels like July is not going to last forever. Cold fronts move, air masses are displaced, the jet stream shifts. Within days, the cold air that is currently dominating Scotland could push southward and drag London's temperatures back down into single figures, or the milder air could reassert itself and push northward, narrowing the temperature gap and bringing Edinburgh back into the seasonal range. That is the nature of British weather operating in the zone it has always occupied. At the intersection of polar and subtropical influences, shaped by an ocean that moderates extremes without eliminating them, positioned on a narrow island where geography amplifies the contrast between north and south. The fact that this can produce a 20-degree temperature difference between 2 cities in the same country on the same day is